Hey everyone, today I'll be solving 1.6.4s, and I've already started a little bit because I was quite excited to teach you guys. So we have Tani, who makes deposit crediting an interest of nominal interest rate 10% convertible semi-annually. So I wrote that down, semi-annually, 10%. And then we have Fabio, who deposits 1,000. So we do know that he deposits 1,000. We do not know that Tani, the amount Tani deposited. So, but this won't be relevant. But I'm just letting you guys know that because we don't know her deposit number, and because we're not even solving for that, we're solving for how much Fabio's account accumulated to. It's really irrelevant, and this is a different style of question. So we have 1,000, different bank account, which credits for simple interest. So reminder, simple interest is 1 plus IT. This is simple interest. Okay, and then this is the important part. End of 5 years, the force of interest. So we're going to find the force of interest first, which is equal, and then we will have to accumulate with, so we need to find Fabio's I to plug into simple interest. Okay, so we'll start with Tani first. We have semi-annually, 10%. So I is definitely not 10%. For her, we have 1 plus I, so this is the original with 1 year. And this equals 1 plus I2 divided by 2 times, and then we do 2 times 1 because this is the years, and then convertible semi-annually. And so this would be 10%. So 0.1 divided by 2, which is 1.05 squared. So we have 1 plus I equals 1.1025. That is this right here. And then so we get that I equals 0.1025. But we do know that for force of interest, which we use with this delta sign, this is equal to ln 1 plus I. So we just plug this one in, because this is just plus 1, which gets us delta equaling 0.09758033. Because we just plug this in and then we calculate the natural log to get this value. Okay, so we do have Tani's, and now we need to calculate Fabio's. So we do have the simple interest formula that I gave you guys right here, 1 plus IT. And to get the force of interest, the formula is the amount function, but the derivative of that, divided by the original amount function. This is the force of interest. So we will solve this using this. So the derivative of 1 plus IT, by deriving t, we get I divided by the original equation, I divided by 1 plus IT. This is our force of interest. And so the question says that the forces of interest of the two accounts are equal. So we have this equal to this right over here. And then, so when you do just simple algebra, you get around 0.0975 equals 0.51204 I, and then you get, there's more values here if you solve it, and then we get that I equals 0.1905498. So this is I for the simple interest. So now that we have this, we can now finally solve for Z, which is what Fabio's account accumulated to. So we'll do it right over here. Z equals, and then he deposited 1,000 times, we use the simple interest formula, 1 plus, and then we have I will just make an arrow right here, saying that that's I, and then we have that this accumulates at the end of 5 years. So we have I5, there you go. And then when you calculate everything, you get that Z equals 1952.75. And this is the amount that Fabio's account accumulated to.